Welcome to Basic Brewing Radio for Thursday, May 16th, 2024. I'm James Spencer. Here at Basic Brewing Radio, we're all about home brewing. This week, Scott Le Fontaine, flavor chemist and assistant professor in food science at the University of Arkansas, shares groundbreaking research in the malting of rice. Scott and graduate student Bernardo Guimarães worked to test the malting characteristics of 19 varieties of rice for use in the brewing process. If you want to support us financially, check out patreon.com/basicbrewing. Many thanks to everybody who's helping out in that way. If you go to patreon.com/basicbrewing, you can see a long list of stuff that you can access if you sign up as a supporter. And many thanks to the new Patreon subscribers who are signing up every week. Your help is very much appreciated. Financial supporters have already seen the video episode that I'm going to post later this week to the general public. It's the one on the delicious and simple small batch Belgian single that Chris Colby and I designed on this show. It was delicious, and now it's gone, unfortunately. Financial supporters got the recipe and a behind-the-scenes video of how that beer came together on the stovetop. My 100% wheat, raw, white IPA is in the bottle and in the keg, and on the way to Matt Giovanisi of Brew Cabin and Josh Secor of Gambit Brewing. I even sent one to Chris Colby along with Steve's Kolsch. Let's see if Chris likes the raw beer any more than the first beer, raw beer that I sent him. I like that wheat beer a lot. I also shared some bottles with Scott Le Fontaine and the folks at the university. I hope they enjoy it too. That beer, it was a challenging beer. It had a stuck sparge, a literal explosive fermentation, and a reinvigoration that I'll explain more fully when we talk to Matt and Josh about it. Matt and Josh are also brewing white IPAs, and I'm hoping that we'll get to taste them all side by side on the show. Really excited about that. On Friday early afternoon, 1 o'clock Central Time, Steve Wilkes and I will be interviewing mad fermentationist Mike Tonsmeyer about brewing hoppy sour beers. Mike recently wrote a couple of articles about hoppy sour beers on themadfermentationist.com. He sent 3 examples from Sapwood Cellars for Steve and me to try. Really excited about that. I'm soliciting questions for Mike on hoppy sours. I've already started receiving some. So if you have questions for Mike Tonsmeyer, Mad Fermentationist, on hoppy sours, please send them to james@basicbrewing.com. And do that, while you're thinking about it, before you forget, because Friday will be on us before you know it. Our friends and sponsors at Imperial Yeast say there's only a month left to get your hands on A37 Pog. Pog is Ebegarden Gweik and is known for producing tropical flavors and aromas at the upper end of its temperature range and more subtle lemony characteristics at the lower end. I brewed my hoppy raw ale with Pog, and everybody that I've shared it with liked it, except for Chris Colby. But it was the malt character that Chris didn't like, not the yeast. I've got 2 pouches in my beer fridge that I'm looking to use in something to ferment on the hot porch. And since Imperial Yeast has a recommended shelf life of 4 months, I should be ready to go whenever I'm ready, especially with those 200 billion cells in each easy-to-open package. Just call me Dusty Stir Plate. I don't use my stir plate anymore to make starters for moderate gravity 5-gallon batches. Ask your local homebrew store about A37 Pog and check out all the dependable deliciousness at imperialyeast.com. That's imperialyeast.com. Okay, every now and then I feel pretty lucky to be in the right place at the right time. Just half an hour from my house, there are food scientists at the University of Arkansas who are working through international collaboration to break new ground in brewing. Brewers have been using rice as an adjunct for a very long time, but surprisingly, there's been very little work done on malting rice and figuring out which varieties of rice have the best malting characteristics. Well, let's head to the U of A to talk to Scott Le Fontaine about what they've found out so far. Scott Le Fontaine, welcome to Basic Brewing Radio.
Hey, it's great to be here.
Where are we at?
We are at the University of Arkansas in the Department of Food Science.
at my alma mater. Although I didn't spend a lot of time out here on the ag side of things. And in fact, I spent no time. There was a little bar not too far from here named Fuzzy's when I was in school. I spent a lot of time there doing research on beer, which is an agricultural product. So I think that counts.
Yeah, I mean, now we have a little, I wouldn't say bar, but we have the ability to make, non-alcoholic as well as alcoholic products here on campus. And that is a University of Arkansas beverage development facility. And we're doing a lot of interesting and novel research in that right now.
Yeah, and this is a fairly recent happening, right? I mean, I think it's exciting that the University of Arkansas is getting into, beer production, beer research. What are the advantages and what's the scope? Why should the University of Arkansas be getting into this kind of thing?
So from a perspective of, caring about an agricultural product that's really important to the state, right? Arkansas grows 40% of the rice in the U.S. And that's, the leading producer of rice in the country. It's our third most important agricultural product. The major exporter of that rice is Anheuser-Busch, right? Mm-hmm. So we have the world's largest brewer accessing one of our main raw ingredients in Arkansas. And so, as a university, we want to make sure that we are growing high-quality rice and have an idea of how to leverage that rice in maybe different brewing applications. And so from a state economy perspective, I think it's really important to understand how to leverage what the state is producing. Now, from a teaching and technical perspective, the university had the brewing certificate program, and that was set up in 2020 during COVID. At the University of Arkansas, it was set up pretty uniquely. It's a 3-college program here: College of Engineering, College of Fulbright, which would be where traditional chemistry and microbiology sits, and then Bumpers of Ag sits in that as well, and that's where food science sits and where the program is housed. But because it was set up in that way where you have those 3 colleges, there's a lot of crosstalk, and that's what brewing is about, right? And so the training side, along with the research side, was very attractive to me. I started here about a year ago, and so I've seen a lot of growth in this program very rapidly, and I saw a lot of potential initially, but that potential has been realized so quickly.
And we're here to talk about rice. Nice segue there, Scott. We're here to talk about rice, and specifically a study that, would it be one of your students conducted specifically on malting different varieties of rice?
Yeah, that's correct. So Bernardo Guimarães joined me from Brasilia, Brazil, last winter, last January. So in his project, he looked at 19 different cultivars of rice, and what we wanted to see was, what would this material do when you malted it? Right. There was some work that was coming out of Italy in Giuseppe Brazetti's lab, but nobody really had looked at cultivars that were being grown in North America yet. And so we reached out to some breeders here at the University of Arkansas, as well as, what's great about Arkansas is you have the USDA rice resources right here in Stuttgart, right? And so we work with them to get some germplasm too, and so and the thought around that is because what we see in the barley industry is barley is pretty susceptible to climate change, right? So yields this past harvest was okay, but the 2 harvests before that in North America, yield was hit pretty hard, and so we see prices rising in barley almost 60%. And so as a craft brewer, that's pretty significant, right? And so really what we are thinking about is trying to find another tool in the toolbox that brewers could use and leverage that is local to us, right? That's the key word here. This is local starch. And we're just thinking about a new way to maybe use that starch in the brewing process that's more accessible to all brewers.
So you're not looking as rice being a replacement for barley?
That is correct. I mean, like, some of the economics work that we're doing right now is pretty interesting. So, for example, for the equivalent amount of starch, you would need half the amount of land as barley if you were going to use rice. Now, the reason for that is rice just yields more than barley, right? So even though in our trials you see a little bit less extract, per land usage, what we would see is you would get more extract out, per acre. Right. And so as you start to flip ahead, there's possibly more and more benefits to this material, right?
Yeah, and talking about different varieties, I don't know much about rice. I knew there was short grain. I knew there was long grain. Thanks to discussions with Origami Sake down in Hot Springs, I then knew that there were different kinds of sake rice. But I had no idea there were. Did you say 19 different varieties of rice?
Oh, there's hundreds of varieties of rice, right? Now, what's interesting about Origami is they're using varieties that are important to the University of Arkansas, right? So Titan being one of them, and then what's interesting is you have a farmer here in Arkansas, like the Isbell family farm, right, that is growing like koshikari and traditional Japanese sake rices. And so there are rices for different application, much like there are different types of barley, right? So what we try to do is look at these North American varieties. And we're not necessarily talking about the varieties right yet, but we're talking about the performance of, this, let's say, the germplasm that we evaluated, and then we can talk sort of about characteristics in terms of the performance of what we looked at.
So let's back up a little bit. In brewing beer, generally, what you use or brewers use is an unmalted product that has to be gelatinized in order to make the starches available for the mash, right? So stop me if I stray from the wrong here. So generally, you either have to do a cereal mash, or you have to basically cook the rice ahead of time, or home brewers especially can use a flaked product, which is gelatinized, through the rolling process essentially, to make it available to the mash. Sake brewers use koji to make in sort of a mash to make the starch available for to be turned into sugar. So. And I guess, has rice always been malted? I mean, gluten-free brewers, at least on the homebrew scale, are using malted rice in making gluten-free beer. But how far back along does malting rice go?
I would say fairly recent. Now, when I said not necessarily being done in North America, there are a couple commercial maltings, Eckert Malting being one, that has been around, I think, for a decade or two. Not really sure, but I know that he started his business because his wife was a gluten intolerant. I haven't yet met them yet, but I know. So you can purvey and purchase malted rice. That would be more California varieties that I would assume that he's malting. I don't know too much about it, but I know that from let's say a gluten-free perspective, mostly what you would see on the market is like millet or sorghum. From a commercial perspective, I would say malted rice would be fairly rare and unique. Now, it might change. And there's reasons for that, right? Like when you have millet or sorghum, they come in with a flavor impact. I find that flavor quite off-putting and and a little bit hard to get over personally. But I think when you taste, there are rice varieties that have some unique flavor, and then there's some rice variety that's neutral. And when we think about how rice has been used in adjunct lagers, it's there to provide that crisp, refreshing taste. And when I think about like having a good gluten-free product, right, like that could be a benefit.
Yeah, typically when brewers use rice as an adjunct, they're not looking for rice flavor.
Yeah, I mean, but what's interesting is you have aromatic rice varieties. And so that exists in the germplasm, much like you would have a variation of different barley varieties that have unique aroma characteristics. You're also going to have rice varieties with varying aroma characteristics, or rye or whatever grain.
Yeah, and in tasting some of the sakes down at the Craft Sake Festival in Hot Springs, there were sakes that did taste like rice. And it was like, in that grainy kind of a way, but, it really showed off, some of those really showed off the character of the rice, and it was very nice. So was there like a wide range of characteristics between the 19 varieties that y'all compared?
So out of those 19 varieties, we actually took 11 to brew with. We just didn't have enough material. So in this, we worked with folks, and we had about, let's say, 3 pounds. So then you malt it, you lose about 20%. Then now we're down, and we were only able to make 5 Plato worts. So we made non-alcoholic beer, but that's something we're specializing on. And I think the characteristics that we see in NA would transfer over into alcoholic beer as well, right? The flavor, that's going to be translatable. So what we're seeing, I think will work. But what we see is, like, generally you have some that are sort of like DMS-y corn, what your typical barley mash would be. We had some that were nutty, kind of almond-like. We had some that were fruity, and another one that basically had a phenolic kind of medicinal Band-Aid-like character. Ooh. So not so great, but that was only one.
But you've got to go through the process.
Exactly. I mean, you have to, because this is a new novel material, people, like, we are really on that forefront right now exploring what can be used. And you're going to have some failures in that, and you're going to have maybe some more preferable options. And so I just think that, we're going to take 5 of those now with characteristics that we think might work in different products. And then now we're going to take that to commercial maltings, right? We're going to do 600 pounds of the top 4 varieties.
Wonder if a local home brewer could sneak some samples of that to use in one of his own batches at his house.
Maybe. We'll see.
I did bring you beer, Scott. It's right. Tried to bribe this scientist.
But we have, there's some really cool varieties. So for example, there is a rice that has a pigmented bran. So it's a purple pigmented bran. And that pigmented color makes it through the brewing process. Oh. So, at the end, you have this rosé-like colored beer.
Oh, wow. That's cool. So let's talk about the nuts and bolts. How hard is it to malt rice? And you were able to do that here on a small scale in the lab?
So we partnered with... before I joined the University of Arkansas, I was on a von Humboldt fellowship in Germany at the Versuchs- für Brauerei. What that means is it's the Teaching and Research Institute in Berlin for beer. And I was working in Dr. Niels Retberg's group, and he kind of manages their special analytics department, and so they have a pilot malting facility there. So what we did is I got here to the University of Arkansas, procured the rice, and then work with them in a collaboration to help malt it, and then they sent that malt back to us. They did some analysis, and so it was really this international collaboration to uncover this work initially.
So did they have to sort of reinvent the process over there as far as coming up with the new ways to malt this grain?
So a lot of the early work was done by that Italian group. So they optimized malting. But what we know about barley, right? Like, even different barley varieties, you're going to have to optimize the malting process for that barley variety. And so what Bernardo and I like to say is we did a shotgun approach. We used what was in research, and then we changed that process up slightly for the VLB equipment. But generally it performed pretty well. Oh. And that was equipment that was being used primarily to malt barley. So the VLB is a great partner because they run the analysis for the barley breeding program in Germany. Yeah, so any new varieties coming out of Germany are going through the VLB, and they malt those barley varieties there, and then they do Congress mashes, and they analyze the characteristics of that wort. So generally speaking, really great partner, and just was like a super effective way to work through that analysis.
So when you made your test beers here, were they 100% rice? Is rice, does it have enough diastatic power to convert the starches? I concentrated too much on the hard word. To convert the starches into sugars itself in the mash?
For sure. That was a super surprising finding. Now, the enzymatic profile is not necessarily the same. So, right, our two main enzymes that we care about in starch degradation that lead to diastatic power are the amylases, right? Mm-hmm. Alpha randomly cutting up the starch and then operating at a higher temperature, and beta sort of coming from the non-reducing end and creating maltose, and that's going to operate on the lower end of temperature. And we hit our brewer's window at 62 to sort of satisfy both of those enzymes. Now, what we see in rice is fairly low amounts of those amylases, but they are in ranges that are greater than most gluten-free grains or above. So you're getting more diastatic power than you would in other grains. Now, gluten-free grains. Now, what's really interesting is we have high amounts of limit dextranase, which is a debranching, or AMG, amyloglucosidase. And so those enzymes operate at a much lower temperature. And I'm just using Celsius here because I have it in my head, but at anywhere between 40 and 55. So when we moved into the brewing trials, you have to treat this material. And when I say they have levels of those limit dextranase and AMG, it's 5x what you would see in barley. So it's significant. It's a lot. And what we see is basically if you hold that material at lower mash rest. So, for example, on our brewing trials, it was we held at 55 for 60 minutes, and then we went up to 65 and held for 60 minutes. And then basically after that, pretty much every variety, like of the 11 we brewed with, 9 self-saccharified.
Huh. Wow.
Yeah. So from a performance perspective, what I think is really interesting about that is it opens the opportunity to be using rice in your brewing process. It might take a little bit more energy. It might be a little bit more time. But from a craft brewer's perspective, if you don't have to change your process that significantly, it opens the door to bring that into your brewery, right?
And does it have an impact on the balance of the ingredients in the mash? Like, say, would it change? I imagine you could put a higher percentage of malted rice in your mash than you could unmalted rice and gelatinized rice.
We have not played with that yet, but for sure, I would imagine that's the case. What we see is we in these brewing trials we were using 100% rice. Mm-hmm. So that's self-saccharing 100% rice brews in the grist bill. Now, as we start to supplement, and let's say we want to make a adjunct lager with 60% barley, 40% rice. I mean, for sure, that's going to perform better than what I mean, not better. I don't know yet. It's hard, but I would speculate and hypothesize that you would be able to get a high amount of extract out from that process.
Yeah, one would assume if it's doing the job by itself, you put some high performing barley in there as well, and you're not going to have any problems.
match made, right?
So did you see any differences in, for instance, the finishing gravities of these beers? I mean, do some of the varieties have more residual sugars left over after fermentation, or, are there any differences in the numbers in that regard?
For sure. There is a difference in the final extract that you can get out. The top extract that we got, and I might have to pull up the paper, but off the top of my head, we're in the low 70s. But that could go down into 50 for some varieties. Now, in the paper, our original paper, again, we were using standard EBC methodology for barley Congress mashes, right? And so now we know we have this enzymatic activity there that's not being, limit dextranase, even though we found some papers from the 90s that show that limit dextranase is also important in barley. We're not designing our mashes to highlight those. You might do a protein rest or something on that low temperature range, but it's not really starch degradation that we're thinking about yet, right? But somewhere I would say like 70 to 73 is where we're seeing our top extracts, or top performers in terms of extract, which, to be honest, when you look at barley, it's not too far off that, 78, right? So, and then, as we started to talk about this, that's where that land usage piece and that sustainability piece came in, because then we started, so we're working with Dr. Lanier Nally, and he is a economist that works on rice. And so he helped to talk to us about that and sort of bring that up for us. And I think that's a super interesting point.
Yeah, as the climate changes, and it is changing, it will be good to have different options, at least, to explore, in the future. To have a knowledge base out there of, if we have to shift gears toward one direction or another in some of these decisions, it'll be good to have that knowledge out there.
Correct. I mean, that's the way I see it. I love this product, right? And the other thing I see with this, right, is that there's a lot of people that are gluten intolerant, and they deserve a great product too. And I see a lot of potential with this grain, and in the flavors that we're seeing in the product already, given my experience with product innovation. So I think like when you look at millet or sorghum and you have this huge flavor that gets in the way of those, like I find some of the products, even though a lot of great development has gone into those, they're just hard from a flavor perspective.
So how did y'all do it? I mean, you get your malted rice back, and now what?
Well, we can talk a little bit about the malting process, right? So that had changed a little bit. So in terms of malting, the steeping takes a little bit longer, so the water uptake in the grain is a little bit more of a challenge. So we had to increase the amount of steep time so that we could get the proper hydration that we needed. And so that increases the amount of time by a day or two. So again, that's more energy, more time in the malt house that's needed. But maybe in these commercial trials, we can think about ways where we could speed that up. And then, we get basically through germ, the way we kilned it was really to create base malts. So we didn't even open the specialty malt discussion on this, but that's what's great about being a researcher and sort of starting down this new process.
Yeah, crystal rice.
Exactly, right? And I think we already know when you have Cocoa Krispies and cooked rice tastes great, right? I'm assuming that cooked rice is also going to taste great in our beverage. So I think from that perspective, we don't know yet as a base malt. And then we get the rice malt here. And
well, before you go down that road, were there extra challenges in, say, like, drying the malt, knocking the roots off, those kinds of processes that, homebrewers generally don't think about it unless they do their own malting. But were there additional, because the size of each kernel of rice is different from barley. So were there any challenges in those regards?
It is a little bit smaller, and that is one concern sort of as we move this to commercial scale. Like, do we need to can you malt this material in the same facility that you could do barley? Because with barley you have those nice plump kernels. Mm-hmm. The other thing about this too, like I think as a population we need to realize that barley is that way is because we bred it that way, right? I mean, I think all of us have seen the corn that used to exist in North America and then what we've done to that material. And so like now that we see that there's efficacy here from a breeding perspective, maybe we create directions toward this if there's appetite. Right, and to me, that's I think what's useful about this discussion is like, just throwing spaghetti on the wall. We've already found, I think, 4 varieties that are on par with modern barley. Right, not even breeding towards this direction. And then, like, say we have continual interest in this, who knows, right?
You could have the rice of tomorrow.
Yeah.
There was a chicken of tomorrow competition back in the 40s or 50s. You could have the rice kernel of tomorrow. So you get your malted rice here in the lab. Now what happens?
Yeah. So we have 2 scales of breweries. We have a grain father that we can do about a gallon and a gallon and a half on, so about a soda bottle amount. And unfortunately for these trials, we could only make that amount because, well, I already kind of mentioned it previously. We had some malting losses, and so that was one of the challenges. So, 20% of the material is gone. And now as we start to figure out what varieties are going to perform, we can maybe further optimize the malting process specific for that variety, much like you would do if you were commercial with a commercial barley variety, right? Like Maris Otter, for example. You know how it's going to work. Like when you have the chemical specs, you know how to treat it. Here, we're sort of flying blind. We have a general spec, but we don't know. So that was some of it. And just to rewind a little bit, like because you asked about challenges, we did over-modify some of the varieties because of that. Right, so we had some under-modified varieties and we had some over-modified varieties because of, and even talking with the commercial malter, we can't even set chemical specifications yet because they're like, we don't know, I mean, and we have a general idea of what we're looking for, but performance-wise, we're really defining this right now. We have 2 brewing systems. We have that grain father, which is about 1 liter in capacity, and so that's what we use for these trials because we had only about 1.5 pounds left. So we designed 5-plater worts, and then we used a yeast that is for being used in industry for non-alcoholic beers called Leviggy. And basically we ended up with fermentations sort of around under 0.5% ABV. But what we did was we took a portion of that wort because like Bernardo and I, we wanted to make sure we were getting full saccharification. So we didn't really design these to be NA. We wanted to really see that malt performance, but because of the lack of material, that's why we had to do the wort quality. But generally speaking, those beers came out and they were clean, they were fine. They just were a little bit lower in flavor, right? So we add more material, probably get a little bit more flavor there.
And you've got sophisticated, you gave me a tour before we started talking, you got sophisticated lab equipment down there to not only rely on human sensory analysis, but also, running them through machines to detect things from a molecular level.
Yeah, so I'm a trained analytical chemist. Luckily, I landed in beer, right? and I love beer. I love the brewing industry. I love brewing science. I mean, from a product standpoint, it changed history, right? And so I like being a part in a scientist in that space. So what we have is sort of like a CSI lab, right? And so, somebody comes to me and they say, why does my product taste horrible, right? Or why does my product taste great? And so then we can look at the raw material and how you grow it, right? Or how you breed it. for similar for certain chemical indices. Or, what's great about the brewing process or the brewing industry, it taught me that raw material quality is important, but so is process, right? So I get this raw material in, maybe it's inferior quality, but how do I make a great product out of that? That's another question that we ask, right? And so with that instrumentation, we have, something that sort of replicates a tongue. That's the liquid chromatograph. Or we have something that replicates the nose. That's the gas chromatograph. And leveraging those two pieces of instrumentation together, we can really dissect any raw material or value-added product.
Wow. So next steps. I mean, you said your next step is you're going to go higher volumes of the selected varieties that you want to evaluate further, and then are you planning on bringing those back here and making more samples here, or will you be partnering with other brewers on that as well?
Yeah, so this is super exciting, right? So we just got funding, a small amount that's going to make this project go into the commercial scale. And really what we'll do is we're going to take that material and get it across the country. I'm going to leverage my network, right? So there's going to be the main R&D breweries in the country.
Wow.
Right? Anheuser-Busch, Boston Beer, some local crafts around here, right? And my goal is to get this material in brewers' hands so that they can test this, see if it works. If there's a there, are they seeing what we're seeing, right? I don't want to push something that's not going to work. Mm-hmm. But generally speaking, I think there's good efficacy with this material, and I think I'm excited about it. I'm excited to get to this step where we have hundreds of pounds of this material and we're not worried like poor Bernardo was worried about every rice kernel, right? And I'm like, don't drop that, right? But now once we have enough of this material, we'll get some back, we'll play with it. The commercial malter that we're going to work with is Raw Malting. They have a R&D brewery, so they're going to get a portion of the malt to play with too. And we might have some general guidelines that people have to follow in mashing, because like I was talking about, you need to have those lower mash rests to really see success with this material. But I'd love for them to design beers that interest them, styles that interest them. So we might be a little bit hands off on that perspective, but hopefully these trials will go in June, and then we'll start to get some results back from that July.
Wow, that's a fast track.
Yeah, once I'm on something, I like to move pretty quick, right? I like to set that guidepost and that guideline. I have a great student in Bernardo. He's very thorough, so very fortunate to have somebody eager that wants to come in, that's excited about that, sees the potential in it, right? So that makes it go, and I'm going to feed that. I'm going to feed that passion, and I got a supporting staff that is interested in this and getting the word out about this too. So without all the pieces that allow for this potential to rise, it wouldn't be possible. But the pieces are here, and so for me, it's just connecting the dots at this point, and how quickly I can connect those dots, right? So.
Well, please keep us posted. Keep us in the loop, because I'm excited about this as well. Yeah,
I would say probably we have a big meeting in the brewing industry at the end of August. It's the World Brewing Congress, and so we have a lot of content that's going to go there. And what I'd like to have happen is either some of the products be made for that, so we can maybe taste with folks at the World Brewing Congress. And for those that aren't familiar with that, the World Brewing Congress is a collection where American Society of Brewing Chemists meet. That's the scientific arm of American brewers, Master Brewers of America, which is a practical arm of American brewers. The European Brewing Congress, which is the collection of European brewers, and the Japanese brewers. And so that meeting should happen every 4 years. It hasn't happened in 8 because of COVID. So I think a lot of new, novel science is going to be there, and I'm really excited to showcase what we have coming out of Arkansas.
Where can people find the study?
So this study is open access in beverages, but if you feel free to reach out to me. You can see me on LinkedIn or just send me an email. The email is scottlaw@uark.edu.
Well, this has been a lot of fun. I'm very excited, and I'm interested to see what you think of my beers.
I'm looking forward to tasting these. They seem really interesting. 100% wheat.
Thank you, sir.
Thank you very much. Anytime.
Well, many thanks to Scott. I'm really looking forward to hearing and hopefully tasting the next results. If you want to get a hold of Scott to figure out how to get your hands on the survey or the study, you can reach out to me, and I'll forward your note on to him. If, in addition, if you have brewing questions, especially if you have questions, remember for my Tonsmeyer that Steve and I are going to interview him early Friday afternoon, on Hoppy Sours. Or if you have show suggestions or just want to say howdy, write to james@basicbrewing.com or just fill out the contact form on basicbrewing.com. And please don't forget to tell us where you're from. Check out our mobile-friendly shop at basicbrewingshop.com. Thanks to everybody supporting us through our Patreon page. Special goodies coming your way. Check that out at patreon.com/basicbrewing. It's all until next time. Till then, thanks for listening, everybody. I'm James Spencer. Production help for Basic Brewing Radio and our website is provided by Kelly Dotson. Basic Brewing Radio is a production of Active Voicing. We'll talk to you next time, everybody. In the meantime, stay well and stay tuned. So long.